So this video lesson is having a look at significant figures. So we're going to look through why we need to care about significant figures and what the rules are for counting significant figures in science. So the reason that we care about significant figures is because when we take a measurement, we take our measurement using a measuring device that has a specific amount of accuracy. So for example, if we are measuring things on a balance, our balance might give us a measurement of something on top of the balance being 1.05 grams as an example, okay? When we take that mass, so we're measuring that on our balance, we know for sure that the balance has measured this digit as well as this one and this last digit. But we don't know whether the balance has measured it as 1.050 grams or whether it was measured at 1.051 or maybe 1.052 or 1.053, for example. Any one of those numbers could have been the next digit, but we don't know because the balance has only 3 digits that it's showing us. And so we're not sure what that next digit would have been, which means the balance rounded so that we got a 5 in this column. So we don't know whether that next number was a 0, a 1, a 2, or a 3 because our balance is not showing us to that degree of accuracy. Now, when we do calculations with these numbers, we want to make sure that we don't change the accuracy of our measurements. So once we take our measurement, the accuracy can't be increased by multiplying a number or by you putting it in a calculator. And so the calculator can't give us a higher degree of accuracy than the measuring device that we started with. So we need to be able to count significant figures so that we know that we're not changing the accuracy of our values. So the rules for counting significant figures, okay, so rule number 1 is that all non-zero digits are significant. Okay, so if we have a number like 1.23, there are 3 significant figures in that number. The 1, the 2, and the 3. Any number that isn't a 0 is a significant number. Okay. Rule number 2. So zeros between numbers are significant. So if we look at our 1.05 again, the 1 is significant, so is the 0, so is the 5. So that would be 3 significant figures. So anytime you have a 0 that is between 2 actual numbers, that will always be a significant 0. Okay, rule number 3, zeros to the left of non-zeros, so non-zero numbers, are not significant. So for example, if we write a number as 0.00153, or we write a number 0.00257, okay, those values, the 1, the 5, the 3 are of course significant. The 2, the 5, the 7, because any number that isn't a 0 is significant. But those zeros ahead of the 153 are not significant. So this has only 3 significant figures. Again, even though those zeros are showing the decimal place, they are before an actual number, and so they're not significant. So again, even in this number, we only have 3 significant figures. Okay. Rule number 4, any zero to the right of a number and to the right of a decimal is significant. This one is a very tricky rule because both of these things have to be true. So we have to have a 0 to the right of a number, and it has to be to the right of the decimal place. So if we have a number like this, 0.00270, or we have a number like no, let's do a different one there. Say we have a number of 2.00, okay? So when we look at this, the 2 and the 7 are, of course, going to be significant because any number that's a number, not a 0, is always significant. The 0 after the 2 and the 7 will be significant because it fits both of this criteria. It's to the right of a number and it's to the right of a decimal place. So this will have 3 significant figures in this number. These preceding zeros will not count as significant numbers. Now, in our second number here, the 2.00, the 2 is, of course, going to be significant, but both of these zeros to the right of the decimal place are also significant because they're to the right of a number and they're to the right of a decimal place. So this will have 3 significant figures. Okay. Rule number 5. And we've only got 6 rules, so we're almost finished with the rules here. So rule number 5 says any counted number has infinite number of significant figures. Okay, so for example, if we have a number like 3 test tubes or 6 fingers, okay, both of those have an infinite number of sig figs. Because they are counted values. And so this is actually going to include as well, anytime we have a universal constant, those will also have an infinite number of significant figures. Okay, and then last rule, rule number 6, which unfortunately is probably the hardest rule to wrap your brain around, is that zeros to the right of a number, but not to the right of the decimal place, are not significant. Okay, so if we have a number like 15,000 or 103,500, so we're going to look at these numbers. So the 1 and the 5 will, of course, be significant, but none of those 3 zeros are significant because they are to the right of a number, but they are not to the right of a decimal place. And so this has only 2 significant figures. In this number on the right-hand side here, 103,500, our 1, our 3, and our 5, no question. Our 0 in between the 1 and the 3 is significant because it's in between 2 numbers. But our zeros at the end are not significant because they are to the right of a number, but they are not to the right of the decimal place. And so this number has 4 significant figures. Now, the only caveat to this rule is that we can actually show that those zeros are significant by placing the decimal place in the right spot. So say we have our 15,000 again. but I write the decimal place in there, that actually shows me that those zeros are exactly 0. And then they are significant. And so then this would be 5 significant figures. But the only way that happens is if the decimal place is shown. If it's not, then those zeros are not significant. Okay, we're going to do a few practice questions. So I'm going to write a few numbers here, and then we're going to go through them and see how many significant figures they have. All right, so if we look at these numbers, 36.77, that's going to have 4 significant figures. The 3, the 6, the 7, the 7. 14.0 will have 3, right? The 1, the 4, and the 0 would count. 0.0033, only the 3 and the 3 are significant, so this has only 2 significant figures. 3 fingers will have an infinite number. It would help if I could spell infinite. Let's try that again. 0.2410 will have 4 significant figures. The 2, the 4, the 1, and the 0 after the 1 are going to be significant. 2.350 is also going to have 4 for the same reason, the 2, the 3, the 5, and the 0, because the 0 is after a number and it's after the decimal place. 1.0009 is going to have 5 significant figures. Those zeros count as significant because they're in between 2 numbers. Now, there's 2 more rules that we need to talk about. And so when you are multiplying numbers or dividing, so if you multiply or divide, okay, your significant figures in your answer must be the lowest number of significant figures from your starting numbers. Okay, so for example, if we take, we're going to do 608.3, and we're going to multiply that by 3.45. So 608.3 has 4 significant figures, and 3.45 has only 3 significant figures. So we can plug that into our calculator. And we're going to get an answer, but our answer is only allowed to have 3 significant figures. So our answer from our calculator is 2098.635. But I cannot record the answer like that because I need to have only 3 significant figures in my answer, which means I'm going to have to not be able to show the 5 or the 3 or the 6 or the 8. Now, the tricky part with this one is that it's going to round out to 210, but I need to show that all 3 of those digits are significant, so I'm going to include the decimal place. Because my that wouldn't be helpful. It's not 210, it's 2100. There we go. And so if I show the decimal place here, then I would have 4 significant figures, which is also not what I want. So I'm going to have to use scientific notation to put my number into the correct number of significant figures. okay? Because I want to be able to show that there are 3 significant figures. And because of our rounding issues, we're going to have to put it into scientific notation. All right, so when we're multiplying or dividing, you are always trying to figure out which of your beginning numbers has the lowest number of significant figures, and that's how many significant figures your answer must have. The other rule is if you are adding or subtracting. So if you add or subtract numbers, okay, then your answer must have the lowest number of decimal places from your starting numbers. Okay, so let's, for example, add these 2 numbers. We have 13.6, and we're going to add 40.07, and so we're going to add those 2 together. Okay, so with our first number here, our 13.6, we have 1 decimal place. With our 40.07, we have 2 decimal places. So that means our answer needs to have only 1 decimal place. So when we add those 2 together, we end up with 53.67, but we're going to need to round that to have only 1 decimal place. So it's going to be 53.7 as our final answer. When we're adding and subtracting, it is not about the number of significant figures. It is about how many decimal places you have. Now, in science, we very rarely are adding and subtracting numbers together, so we don't use this rule a lot. We're doing a lot more calculations with multiplication and division. And so we want to be very careful about determining what calculation we're doing, and that tells us how many significant figures we can put into our answer, or if we're adding and subtracting, how many decimal places our answer can have. So that's it for this video lesson on significant figures. There is a practice worksheet